we take on a bold idea from the frontiers of physics and philosophy. What if space-time, the very fabric we believe underpins the universe, does not actually exist? It sounds shocking. After all, we're used to hearing about space-time as if it's a real physical thing, stretching, bending, curving under the influence of gravity. But many physicists and philosophers now argue that space-time is not an object. It's a map, a description of happenings, not the happenings themselves. And understanding this distinction clears up centuries of confusion about time itself. What is space-time? In modern physics, space-time is defined as the complete set of events that occur throughout the universe, from the Big Bang to the far future. It's a four-dimensional coordinate system that records where and when everything happens. If you imagine a car driving down a road, physicists often draw a space-time diagram. One axis for time, another for position. The car's motion appears as a line, marking each moment of its journey. That line, called a world line, is simply the record of where the car is at each instant. Now extend that logic. Your life, my life, the Earth's orbit, even the Milky Way's drift across the cosmos, all can be mapped in space-time. It's our best catalog of everything that has happened, is happening, and will happen. But here's the key question. Does the map itself exist? Or is it just a description of how events unfold in an already existing world? To see the problem, let's break down the word exist. Objects exist. Cars, buildings, people, planets. They persist, we can interact with them, and they endure through time. Events, on the other hand, don't exist in the same way. Events happen. You lose a tooth. You hear good news. The Earth completes another orbit. Each of these is a happening at a place and time. But once they happen, they are not sitting somewhere, waiting for us to revisit them. Time travel stories make it tempting to think the past is like a place we could go back to, or the future a destination we might visit. But in reality, there is no evidence that events themselves continue to exist once they've occurred. If they did, we would need something like a time machine to observe them right now, which we don't. Philosophical views of time. This issue has divided philosophers for centuries. Eternalism says all past, present, and future events exist. The growing block view says the past and present exist, but the future doesn't yet. Presentism says only the present exists. The past once did, and the future will. General relativity, meanwhile, describes a four-dimensional continuum. Many people mistakenly take that continuum as evidence that space-time itself must exist as a physical thing. But here's the catch. All of these perspectives hinge on treating events as if they exist, and that may be the fundamental mistake. Why it matters. If we stop thinking of events as existing things, and instead see them as happenings in an existing world, we resolve a lot of confusion. For example, paradoxes about time travel, like going back to kill your past self, only arise if you assume past events still exist as destinations. Once you recognize that events simply happen and don't persist, those paradoxes dissolve. The same goes for philosophy. Many debates about whether time is real or whether the flow of time is an illusion rest on the assumption that events exist as objects that can be labeled past, present, or future. But if events don't exist, they only happen, then tense and order are just ways of describing relationships among happenings, not properties of objects. And in physics, relativity remains as accurate as ever. The math of space-time still predicts gravity, black holes, and the expansion of the universe. But we no longer need to imagine space-time itself bending or stretching. It's simply a description, a map of how events unfold. The bottom line. Space-time is one of the most powerful ideas we've ever developed. But calling it something that exists is like calling a map the territory. The map is indispensable, but it is not the world itself. Objects exist. Events happen. Space-time, therefore, does not exist. It describes. And in that simple shift of language, we gain clarity without losing a single prediction or scientific tool. So, the next time you hear about the fabric of space-time curving under the pull of gravity, remember this. It might just be our most useful illusion. For now, space-time remains one of our greatest descriptions of the universe. But perhaps not the universe itself.